motion of a rocket. Motion of a rocket. So first diagram. So this is the diagram. Velocity V, velocity U. Here m naught equal to initial mass and m equal to final mass. Here thrust. This is the diagram for motion of a rocket. M naught equal to initial mass, m equal to final mass. So the rocket is an example of system of variable mass. Already we know that system of variable mass. The rocket is an example of system of variable mass. Next, the rocket consists of a consumption chamber in which liquid or solid fuel is burnt. The rocket is an example of system of variable mass. So in this chamber consists liquid or solid fuel. Here consider let capital M be the mass of the rocket and m naught is the mass of the rocket system including fuel. Here consider capital M and capital M naught. Here let capital M be the mass of the rocket, and m naught is the mass of the rocket system including fuel. M naught equal to rocket mass plus fuel mass. Here capital M What is the capital M? Mass of the rocket, and m naught is the mass of the rocket system including fuel. That means m naught equal to, we can write rocket plus fuel mass. And let v is the velocity v is the velocity of the rocket moving upwards moving upwards at any time t. At any time t. So after time interval dt, the amount of mass dm is coming out from the rocket in the form of gas jet, and suppose minus u is the velocity of the gas jet with respect to the rocket, and the velocity of the jet is finally written as, we can write v minus u. Here let v is the velocity of the rocket moving upwards at any time t. After dt time means some interval. Let in a time interval time interval dt, the amount of mass the amount of mass dm is coming out from the rocket in the form of gas jet. After time interval dt, the amount of mass dm is coming out from the rocket in the form of gas jet. Next, suppose minus u is the velocity of the gas jet with respect to the rocket, and the velocity of the jet, the velocity of the jet is finally written as v minus u. Here minus u is the velocity of the gas jet with respect to the rocket, and the velocity of the jet is finally written as v minus u. Next, now the total thrust acting on the rocket is acting on the rocket is F reaction equal to V minus U dm by dt. So here the total thrust acting on the rocket is, we can write F reaction equal to V minus U into dm by dt. Next, as the weight of rocket acts in the downward direction, that value F equal to, we can write V minus U into dm by dt minus m into g. After that, from Newton's second law, we can write F equal to dp by dt. As the weight of rocket mg acts in the downward direction, in the downward direction, F equal to V minus U dm by dt minus m into g. Equation 1. The weight of rocket acts in the downward direction, that is F equal to V minus U dm by dt minus mg. Next, from according to Newton's second law, according to Newton's second law, F equal to dp by dt, we can write d by dt, p value m into v. So from this, m into dv by dt plus v into dm by dt. This is the second equation. So from Newton's second law, already we know that F equal to m into a, or F equal to, we can write dp by dt. So F equal to dp by dt in this equation, p value m into v. So d by dt into mv. We can write this one m into dv by dt plus v into dm by dt. From equations 1 and 2, from equations 1 and 2, we can write from equations 1 and 2, we can write this value equal to this value. That means m into dv by dt plus v into dm by dt equal to v minus u into dm by dt minus m into g. Here v into dm by dt and here one value cancel, m into dv by dt plus v into dm by dt equal to, we can write v into dm by dt minus u into dm by dt minus m into g.